Welcome to This Explainer. Today, we're diving deep into the realities of pesticide pollution. We're going to take a highly structured, evidence-based look at the chemicals we currently rely on to protect the global food supply. We'll examine their biological mechanisms, their hidden costs, and, crucially, the science-backed sustainable solutions we really need to start transitioning toward.
Here's our roadmap for today. First, we'll cover what pesticides actually are, then look at their categories and global usage. After that, we'll break down the acute health effects, follow up with the long-term consequences, and wrap things up with some sustainable agricultural alternatives. Let's get into it.
All right, part 1. What exactly are pesticides? Let's define the chemicals protecting our crops.
So, to put it simply, a pesticide is any substance that's designed to attract, seduce, destroy, or just mitigate a pest. But here's the kicker. They belong to a class of chemicals called biocides. And if we break that word down, biocide literally translates to life killer. Now sure, we mostly use them as crop protection products, defending our agricultural yields from aggressive weeds, plant diseases, and hungry insects, but at their very core, their fundamental mechanism is to terminate living organisms. It's a heavy thought, right?
Moving on to part 2, categories and global usage. We'll be examining the 12 major types and just how far their reach really goes.
Now, we can actually group these into 12 distinct types based on their biological targets. On one hand, we utilize agents targeting plants and microbes. We're talking herbicides, fungicides, bactericides, antimicrobials, and yes, even the everyday disinfectants and sanitizers you probably have sitting under your kitchen sink right now. On the other hand, we engineer compounds specifically to combat insects and animals. This includes insect growth regulators, termicides, broad-spectrum insecticides, nematicides, and various repellents. So as you can see, it's a massive, highly specialized chemical arsenal.
And this brings us to an absolutely crucial reality. Pesticides are literally the only toxic substances we intentionally release into our environment just to kill living things. And their chemical footprint? It is everywhere. We aren't just discussing massive industrial agricultural fields here. These biocides are deployed in our homes, they're sprayed in our local parks, applied in schools and commercial buildings, and used heavily in forest management and along public roadsides. It's a truly universal footprint.
To really put the gravity of this footprint into perspective, just think about the number 9. According to the Stockholm Convention on Persistent Organic Pollutants, 9 out of the 12 most dangerous and persistent organic chemicals on the planet are organochlorine pesticides. 9 out of 12! These are incredibly stubborn compounds that don't easily break down, which means they just linger in the environment and slowly accumulate right up the food chain.
Let's pivot to part 3, acute health effects. What are the immediate dangers of exposure?
When agricultural workers and handlers are out there on the front lines, the immediate physical symptoms of acute exposure they face are honestly pretty severe. We're talking intense abdominal pain, dizziness, blinding headaches, nausea, and vomiting, not to mention some really debilitating skin and eye problems. But it escalates way past simple nausea. For example, take pyrethrins. These are super common insecticides you'd find in everyday bug killers. Well, if you breathe them in, they can actually trigger a potentially deadly respiratory condition. So the danger isn't just out in a distant farm field. It could literally be sitting right there in your garage.
Let this data point sink in for a second. 500,000. In China alone, it's estimated that 500,000 people are poisoned by pesticides every single year, resulting in roughly 500 immediate deaths. That is a massive, ongoing occupational safety and public health crisis just from handling these chemicals.
Which brings us to part 4, long-term health consequences. We're looking at chronic diseases and multi-generational impacts. So the epidemiological data linking pesticide exposure to oncology is frankly extensive. We consistently see increased cancer rates among the farm workers who apply these chemicals day in and day out. The medical literature shows incredibly strong links to leukemia, lymphoma, and cancers of the brain, kidney, breast, prostate, pancreas, liver, lung, and skin. I know, it's quite the list. But perhaps the most tragic part of all of this is the multi-generational transfer of risk. Basically, a mother's occupational exposure to pesticides during pregnancy is directly associated with an increased risk of her child eventually developing leukemia, Wilms tumor, and brain cancer. And the risks aren't just oncological. The neurological dangers are immense too. Look at this. Studies show there's a 70% greater chance of developing Parkinson's disease in individuals who are exposed to even low levels of pesticides.
It doesn't take some catastrophic chemical spill to cause harm. Just continuous, low-level environmental exposure dramatically alters your neurological outcomes. Expanding on those systemic risks, folks with Parkinson's are actually 61% more likely to report direct pesticide applications somewhere in their history. Plus, long-term exposure is linked to an increased risk of dementia. The National Institutes of Health even found that licensed applicators who used chlorinated pesticides for over 100 days in their lifetime face a significantly higher risk of diabetes, along with chronic dermatitis. Now you might be wondering, what about regulations? Well, despite these documented risks, major regulatory gaps still remain. For instance, the EPA completed a massive 10-year review of organophosphate pesticides, but researchers pointed out that it did very little to properly account for developmental neurotoxic effects.
We also absolutely have to talk about reproductive interference. When we look at overarching effects during pregnancy, there is very strong evidence linking pesticide exposure to birth defects, fetal death, altered fetal growth, and dangerously low birth weights. And if we look strictly at fertility itself, specific chemicals like dibromochlorofan and 2,4-D have been scientifically linked to impaired fertility in males. The biological interference here is just incredibly comprehensive.
All right, let's lift ourselves out of the problem space and dive into Part 5, Sustainable Agricultural Alternatives. How do we move toward biological and cultivation solutions?
The good news is, science actually provides us with two fantastic avenues for intervention here. First up, we have biological controls. So instead of relying on chemical toxins, we can use pheromones to disrupt pest mating, we can introduce natural predators and parasites, or use highly specific biological pesticides, things like entomopathogenic fungi, bacteria, and viruses that only target the pests we want to get rid of. We can even use genetic engineering to interfere with insect breeding. Then we have the second avenue, smart cultivation practices. This means moving away from massive monocultures and leaning into polyculture. It means utilizing crop rotation, planting clever trap crops to literally lure pests away from our cash crops, and applying composted yard waste to rebuild incredibly resilient soil biomes. The science really does give us a clear, actionable path forward.
And that leaves us with a pretty massive question to ponder today. Armed with all of this epidemiological data, are we going to just keep intentionally releasing these toxic biocides into our environment and absorbing those immense health costs? Or are we going to aggressively embrace the biological and cultivation alternatives that are so clearly required to protect our agricultural future, our workers, and the next generation? Thank you so much for joining me for this explainer. Keep exploring the science, and I'll see you next time.